What else you want to look at? Hopworth, what do you got?
46.
46.
I did it, but oh yeah, the question was secant equals 0. Yeah, I flip it to say 1
We'll get there. So in this one here, there's really nothing I can do aside from GCF. So I factor out a secant. I have secant of x times secant plus 2 is 0. So then I go ahead and go set it up. So secant of x is 0, and secant plus 2 is 0. Well, this means what angle has a secant value of 0? Well, in my mind, I like to think of, when I'm solving that part, I like to always think about it in terms of sines, cosines, and tangents, if possible. So what I have to do is reciprocal it. The reciprocal of secant would be cosine. So this is what angle has a cosine, but not of 0, but of, what's the reciprocal of 0? Undefined. Is cosine ever undefined? No. Cosine is a continuous function. Can't do that part. Okay. Right. What's that? Because tangent, when you're looking at your quadrantals, remember tangent has asymptotes.
Yeah. So cosine you can't.
Correct. Correct. Now, the other one then, excuse me, it's basically asking you what angle has a cosine of -1/2. That's what that one's getting. If you go ahead and flip it, after you subtract 2, and you get what angle has a secant of -2, and then you go through there. So cosine being negative is going to get you to quadrants 2 and 3.
There's going to be 2 pi over 3.
Very good. 2 pi over 3.
Yeah, unit circle.
And these are both b plus 2 pi x. Which one? Sure.
Was it really?
There's a nice subtle trick on number 48. Very, very subtle.
Is it chlorine?
It is. It is. When you rewrite this, you have 2 sine x plus 1 over sine x equals 3. How do you get rid of the fraction? Multiply everything by sine. If you multiply both sides by sine, you get 2 sine squared and a plus 1 after it.
Oh, I did that, but I like moved the cosecant to the other side, and then I was doing something.
Oh, you could do that, but it's many more. It just gets messier.
Okay.
You should
I was
theoretically.
with, like, the negatives and stuff.
Yeah, theoretically, you should be able to get to the same spot, because then this just turns into a regular factoring problem. Okay. Really? You again? Hey, guys. It's the wrong room. This is 118. This is 218.
Stop.
Mr. Zach. You guys. You get mail. All right. Do I need to factor this? Are you guys okay with factoring? Because this is kind of like the same one we've been doing, isn't it? Are we okay, or do you want me to factor it? We're okay? All right. Bless you. What else we got? The only type moves I have, the weird ones.
Wait, I need to copy this down like super fast.
Wait. It's T, H,
I don't know. What else are we going to look at? We're okay on equations?
Sure. I feel like I understand how to do it, but I feel like sometimes like applying.
I'm kind of nervous about the fact that no one mentioned anything about.
Wait, I do 40 games.
I can't do that. So.
Don't you just like flip it so you get like a and then you like or you multiply by like and then
Again, there's a really easy way to work with 41. Get rid of the fraction. You don't have to do exchange-o. Just multiply both sides by cosine minus sine. If you multiply both sides by cosine minus sine, you're going to get 1 on the left. And then on the right, you get cosine plus sine, cosine minus sine. This case works out okay in our favor, because if you FOIL that out, it just becomes a difference of squares. A squared minus b squared. So you get cosine squared unlike the problem earlier that had this, where we went to that double angle, this case we don't need to. Because we can rewrite either cosine squared or sine squared in terms of each other. So let's rewrite cosine squared as a sine squared. Cosine squared is what in terms of sine squared? It's 1 minus sine squared. Okay? So this gets 1 is 1 minus sine squared minus the sine squared. How many sine squareds do I have now on the right-hand side? 2, so it'll be a negative 2. So I have 1 equals 1 minus 2 sine squared. So far, so good? Okay. So now I'm gonna put the negative 2 sine squared on the left and move the 1 to the right just to make everything positive and stuff. Okay. So I'm gonna get 2 sine squared is 0. What's 0 divided by 2? 0. So this is asking you what angle has a sine value of 0. Are you sure about that?
It's 0. No, not 0.
What comes first in the alphabet, x or y?
X.
What comes first in the alphabet, cosine or sine?
So sine is the y, and sine is 0 at 0.
Right. So we are 0 here and 0 here. So my answers would be 0 plus pi n. Or pi n. Or pi n. And that works. Now, even though I solve that in terms of sine, if I solve that in terms of cosine, I get the same. It would work out to be the same. Okay? No. And they just yelled about that too. Yeah, I'm the teacher. I can do whatever I want. So there. Well, I can't like literally throw you out a window, so I could try. Is it okay if I write it as 0 plus pi n, or what if I just wrote pi n? Is that the same thing?
Yes.
Yeah, same thing. Okay.
It just looks.
Yeah, it looks weird because you're used to having something out front, but it means the same thing. So equation-wise, tomorrow, what I'm looking at you guys being able to do is it's going to be 2 of them: one general solution and one within one revolution. Remember, general solution will say, hey, solve for the general solution, and that's when you have to worry about your tacking on n's. Why do you have to worry about an n? Because there's an n in the word general.
Or you just remember.
Or you just do that too. Now, one revolution, you're just listing out all possible angles. Okay? Not smile. Anyway, the other part about the equations then is my guess, if I were a betting person, which I'm really not a gambler, I'm not one to like to gamble.
But you're going to teach us a whole gambling unit.
True, but I'm also going to show you that the odds are never in your favor.
Like your lottery thing?
Oh yeah, the odds will never be in your favor when you're talking about gambling. It's about risk versus reward, is what you're looking at. So if I were a betting man, like I said, which I'm usually not, I would make sure that I remember the equation stuff, especially these last couple of days, because a lot of them had that quick little step of multiplying both sides by something. turning something into some form of a quadratic. Working with a sine squared is 1 minus cosine squared. Tangent squared can be rewritten as secant squared minus 1. You guys know sine squared plus cosine squared is 1. The two that still can be kind of fuzzy is 1 plus cotangent squared equals cosecant squared, and 1 plus tangent squared is secant squared. So let me give you the dumbest way possible to remember which one's which. Co. Well, if you write it out, then it's just a matter of solving the literal equation. Just moving it around, okay? Now, what I mean by this cotangent, cosecant. But which one goes where? Think of the lettering. Cotangent, COT, cosecant, CSC. Which comes first in the alphabet, O or an S? So the O goes first. 1 plus cotangent, COT, is cosecant. It's stupid. But if you remember that, you're going to be okay. Right? I know. You went, what did you say? Okay. Are you okay with the equation stuff? I think we've kind of done a lot of the tricky ones. Now, here's what I want to look at. I'm going to go back. Hey guys, I'm going to go back. Ladies and gentlemen, I'm going to go back into the packet of death of Simplify Verify.
No.
Oh my God.
And
Oh my God. What if I don't have that packet?
I might have actually that one. And what I want to do is pick out a couple of them that I think that are a little bit more challenging, say. Yeah. And kind of walk you through a few and things that I would look at. Let me see if I can pull up the ones that I did with second hour. Yes, the answer is yes.
I think how hard it was. That's the problem with math. It's never easy. And then you always have to figure it out. Like all the stuff that you never understood, like when I don't know, like that's like
Sometimes I get the word test, but if you don't get it, which number is this?
It's page 4, number 4.
Page 4, number 2.
Okay? Page 4, number 4.
Which page 4 is what?
I
Well,
wrote
it has the 4 on the bottom. It says 4 on the bottom.
Oh, but it was page 1. Did not know that.
So here's what I want to look at, guys. I'm going to go through a couple of these that have kind of the, it might not be a exact example, but at least it gives you a first step, shall we say. So when I see something like this, and I have a, in this case, a verified, even if it wasn't a verified, I had two fractions put together, what in your mind should you be thinking of right away? Common denominator, exactly. Anytime you see addition or subtraction, whether it's simplify or verify, and you have fractions to begin with, it's probably saying, hey, knucklehead, try and get a common denominator. So, what's going to be my common denominator of these?
Cosine plus sine.
I get CO5. Thanks, jerk. So, fraction on the left needs a what? Needs a cosine. So cosine times cosine is, fraction on the right needs a 1 plus sine. Okay. So fraction on the right I'm going to have to actually FOIL. Very good. So in this case here, it's not something that's going to be horrible that you have to worry about foiling out, because it's the same thing times itself. So it's like junk squared. It's junk times junk. I'm going to get cosine squared plus 1 plus 2 sine plus sine squared.
Hey, both of those are squared.
Cosine squared plus sine squared equals
I'm getting it. So just by foiling that out, now I'm just not rewriting my denominator just because I'm trying to save ink, you know, budget cutbacks.
It's a smartboard.
In that numerator, there's a cosine squared plus 1 plus 2 sine plus sine squared. Is there some, I don't know, identity that might be hiding there? Oh my God, there is. What is it? Right here, I have cosine squared plus sine squared, so I know that I can rewrite that as 1 plus 1 plus 2 sine. So now, what's 1 plus 1? 2. And you guys are ahead of me by a step or so, but let everybody else catch up here. At this point, notice by not distributing out the denominator, which I recommend not to do until you very, very, very have to, you kind of had this premonition of what's going on in the numerator. If you factor out the 2 out of the numerator, you're left with a 1 plus sign. Yep, and the reason that I can simplify it out is because it is a term, because it's being multiplied via the parentheses. So you do your and then cosine flips up to become, and you seek and destroy it.
That actually wasn't that bad.
that joke's just the same.
Stop!
Because it's the sin to be a tangent without a. Because it's the sin to be an angle without a tangent.
I think you're gonna have to.
It's not very funny. I get it. Whatever. Tangent squared plus 1 plus tangent. This is 18 on that same page. This is 18 on the same page. Hold on. Don't get ahead of yourselves. So you have tangent squared plus 1 plus tangent times secant equals 1 plus sine over cosine squared. Let everybody else write it down. When I start to see stuff like this, again, I might start thinking, all right, I've got tangents and secants. I can write sines and cosines and things of that nature if I had to. But I also see that since I have tangents and a tangent squared, and there's a secant in it, why not rewrite the tangent squared as a secant? So tangent squared plus 1 is secant squared. So I'm going to go to that right away, because then you get what do those two parts have in common? Secant. I can't factor out a tangent up here because there's too many plus signs. But once I combine it into this part, now I can get a GCF. My GCF here is secant. Okay? Everybody with me so far? Now, knowing that I have to get to some fraction, now what I want to do is work with the stuff on the interior of the parentheses, because there's addition, which means I can write them as a fraction and see if I need to get a common denominator as well. Okay? So secant is 1 over what? Tangent's 1 over what? Do these guys have a common denominator? Which means I can combine them and get I'm almost to where the problem started, but I have to do what?
Make the secant a 1 over cosine.
Secant 1 over cosine.
Right. So now all I have left to do is make this a 1 over cosine, multiply in, and you're going to get 1 plus sine is cosine squared.
Could you do it by converting everything to cosines and sines?
Yeah, you could get there too. I just saw this and I thought it was a little bit quicker because I knew that tangent squared plus 1 gets me a secant squared and I get GCS right away. Okay? You could, there's many ways of doing it, all right? Excuse me. So, remember, when you do stuff like this, it's a matter of looking at what you start with. If you have a squared term, and then that squared term has a non-squared partner that's Pythagorean, try and rewrite, okay? Because a lot of times you might get GCFs and things like that. What's the other one? What was the next one?
Why is it? So when you multiply that in, why does it go to the bottom?
Oh, what's the secant is the same thing as saying 1 over cosine. And then when you have fractions,
Multiply that 1 over cosine.
yeah, because the fractions you're just multiplying straight across. So it's 1 times 1 plus sine, cosine times cosine is cosine squared.
Okay.
This is 6 on page 5.
Page 5.
Yep. I know we've done one similar to this before, but I want to reiterate the idea of what do you do when you start with subtraction and then you flip into multiplication. Exactly. What's up, Sadie?
If it's like tan squared, you convert it to sine over cosine, where do you put this?
On both. Well, you were half right. This was fine. Fault to save it.
What? Yeah, because mine is still always recorded.
So, big trick. Anytime you see subtraction and then it's saying to get to multiplication, that meant you had to get a common denominator. Also, a lot of times if you don't see, if this was just a simplify problem and you saw something like this, if you just saw that, in your back of your mind, saying not knowing where you need to go, probably means, oh, if there's subtraction, I should probably get a common denominator to see where that leads me.
Should you change it into sine over cosine?
Yes, I would change this into sine squared over cosine squared minus sine squared over 1. What's going to be the common between cosine squared and 1?
Cosine squared.
Good. Fraction on the left, didn't need it. Fraction on the right, needed it. Are you okay with me on that?
Then you can factor out the sine squared.
Exactly. So now I can factor out the sine squareds on the numerator.
You couldn't you turn that cosine then? Because it'd be like cosine minus 1 into a sine squared.
We're getting there.
I'm just making sure I'm on the right track.
You're You're on the right track.
I did all this homework.
Now you're getting it. Now you got it.
Yay.
So now, what can I rewrite 1 minus cosine squared as?
Science squared.
Sine squared. So what happens then is that you wind up with sine squared cosine squared, I'm sorry, sine squared over cosine squared.
And then you expand.
Yeah, because now, since it's all multiplying, I can put that cosine out of the denominator underneath either one of those two numerator parts, because you just multiply straight across. You get sine squared over cosine squared, which is, yep, nope. Because what if you had this? What if it was 8 times 5 over 4? Isn't that just 2 times 5? If this was 8 times 50 over 4, or let me make this multiple. Could I just do 2 times 40 or 8 times 10? Did it matter? It doesn't matter. Same basic rules for the fraction work with numbers hold true with letters. Wish I could do some hours. Anyway. Hi, LeBlanc!
Can you explain again, just really quick, how you do when you make the common denominator, how you know what goes on the numerator?
Yeah, real easy. If you think of it this way, in terms of 2/3 and 1/5. If I want to do that, what would be the common denominator between a 3 and a 5? What would you have to do? You multiply them together. So if you multiply them together, you get a 3 times 5. Do you agree?
Yeah.
Fraction on the left already has a 3, so it needs to be multiplied by a 5. Fraction on the right has a 5, it needs to be multiplied by a 3. It means the exact same thing if this was 1 over sine plus sine over cosine. You do the exact same thing. You have to multiply them together. Fraction on the left has a sine, it needs a cosine, so it's 1 times cosine. Fraction on the right has a sine, it needs a, has a cosine, it needs a sine. Yeah. That's all we're doing. You're doing the exact same process as you would if they were numbers,
Okay.
but you just have letters.
So we do this for addition.
Addition, subtraction. Yep. Yep. Okay. Did that help?
Yes.
We got.
So the quiz is over just what we've learned.
2 simplify, 2 verify, 2 equations, 1 general equation, 1 revolutionary, not revolutionary equation, one
revolutionary
it's, yeah. Forrest Gump, no, it's Abraham Lincoln. Anyway, something along those lines. Yeah, it's
It's all like what we've done. Okay.
But it's all
When
like
you said that, I was
I
like,
didn't know if we were going back to grasp it earlier.
no.
We should do another graph quiz. That graph quiz was great.
We should do the test, but only graph.
Did everyone in the class the class is doing pretty good with graphing?
Yeah, graphing was really easy.
I was probably looking at
It's called visual. What's the next session we do after all this?
We get into sequences and series. Oh yeah, hey, by the way, on Friday, we start sequences and series, which means you need to find your calculator. Yes, I know it's been since I looked this up second hour. I looked back and looked at the calendar as far as when did we last use a calculator? Well, in math. The last time we actually used a calculator
Thanks to Mr. Gunderson.
was...
I don't know how long you
Actually, I can't read this. I'm going to use the
like
view.
solar power, right?
Yeah.
It's not that old.
Sine, cosine graphing. The last time you guys touched the calculator was March 7th.
That was before I got hurt. That sounds a long time.
Seriously, if you go back to it, you guys have been doing trig for 6 weeks. Forever.
We must be experts by now.
I mean, seriously. And then that's the whole idea of this class. This class really is a get you ready to do trig in pre-calc. Okay? Yes, sir?
Just to be clear, it would be like the amplitude stuff on the
No, sir.
Okay.
No, just verify, simplify into equations.
I was just making sure because we need to take a test over amplitude.
Yeah, it was all built into that one, all right? I'll have stuff like that again on the final, because those are really easy questions to put on a final as far as multiple choice is concerned. I can ask you amplitude period questions real quickly off of just a given equation, all right? Yes? I haven't decided. I haven't decided on that yet. I don't know. I'd like to, but I don't know if I have time to. Oh, I sent you guys out an email about the schedule for finals. It's going 2-3-2 this year. So you have your first 2 early bird on the Thursday, the next 3 periods on Friday, and then the final 2 on Friday or on the following Monday. So
First day is gonna be. So what if I wait about
actually, I have been told for certain, but I'm going to go ahead and say that's usually what we do. But that would require.
I think my son.
You still on 4-5 is in the middle.
Oh my gosh. I
What's the second?
4-5. That's the middle of the second day.
No. Oh yeah. Yeah.
Are you kidding me?
That's time.
No,
I mean,
I
spend the whole time studying.
I think so.
Whoever comes in after that.
There was one other one I wanted to show you real quick, and I forgot what it was.
Oh my gosh. I'm gonna go crazy. I'm gonna do more what I Go home after that.
Just go home and come back. What are they gonna do? Give you an afternoon study hall?
Let us go vacation on Monday, so I have to do my I'm ahead of you. But I don't think that'd be a wise
Real fast, this will be the last one that I'm going to show you here for right now, because we haven't looked at this style in a while. One of the tricks for when you have multiple parts in the numerator and a singular statement in the denominator, split them. And that works for whether or not it's 2 terms in the numerator, 3 terms, 4 terms, whatever. That just means that it had already found and gotten and worked through its common denominator. They've already done that for you, so you don't have to worry about the rest. So now you just split it into 1 over sine plus cosine over sine and go on from there. Okay? What is 1 over sine? What does this equal? Is it cosecant or?
Never mind, I'm like out of
You're right, it's cosecant. It's cosecant plus what? Cotangent. And that's all you can do. Okay? Just for showing you guys out. And then it works the same thing if this was squared. You can put a squared here and a squared here and go on and on and on and on and on. Alright? Are there any other styles you want to double check, make sure you're okay, or any other particulars off the packet of death that you wanted to look at, that you looked at and said, I don't know what to do? LeBlanc, what do you got? Which page? Bottom right, it says number on it.
Oh, yeah.
Okay? Easiest thing to do here is rewrite the denominator. What's 1 plus tangent squared? And now you have a singular part in the denominator, split your fraction. You okay with me so far?
Oh, I get it.
1 over secant squared is the same thing as saying cosine squared. Here, I'm going to quickly rewrite that as a complex fraction. Sine squared over cosine squared over 1 over cosine squared. So this comes up and I multiply by cosine squared over 1. And I get cosine squared minus sine squared.
That's not pretty.
It's not pretty, but it's quick. But it asks you to verify it to equal 1 minus 2 sine squared. So what do I rewrite the cosine squared as?
1 minus sine squared.
Yeah. So it's not that bad. What you did is you used Pythagorean identity up front.
How did you get cosine squared minus sine squared?
Cosine squared is 1 minus sine squared. Remember cosine squared plus sine squared?
Where did you find cosine squared?
Oh,
Oh, right.
so I split it via once I got that Pythagorean identity up at first, I split the fraction and just rewrote things in terms of their reciprocals, sines and cosines and things. Okay? A little bit louder this hour, isn't it? Second hour, it's like, I can't get you guys to say anything.